Students, in my previous episode, I have discussed about the resource environment interface and classification of resources. In today's episode, let me explain about the distribution and utilization of water. The episode is planned and consists of the following submodules: 1. Origin of water, 2. Forms of water, 3. Characteristics of water, 4. Distribution of water, 5. Utilization of water. Let me begin with a brief introduction. Water is very important component of the biotic or physical components. It is very essential element for all types of life in the biosphere. Water is a chemical substance that is composed of hydrogen and oxygen and is vital for all known forms of life. Now let us discuss about the origin of water. Much of the universe water may be produced as a byproduct of star formation. When stars are born, their birth is accompanied by a strong outward wind of gas and dust. When this outflow of material eventually impacts the surrounding gas, the shock waves that are created compress heat and the gas. The water is observed is quickly produced in this warm dense gas. Water has been detected in interstellar clouds within our galaxy, the Milky Way. Water probably exists in abundance in other galaxies too, because its components hydrogen and oxygen are among the most abundant elements in the universe. Interstellar clouds eventually condense into solar nebula and solar systems such as ours. Forms of water. Water refers only to its liquid form or state, but the substance also has a solid state, ice, and a gaseous state. Water vapor or steam also. Water on the earth moves continuously through a cycle of evaporation or transpiration. It is called evapotranspiration, precipitation, and runoff, usually reaching the sea. Over land, evaporation and transpiration contributes to the precipitation. The three forms of water are water vapor, liquid water, solid or ice water. Water vapor is present in Earth's atmosphere. The percentage is 0.40% over full atmosphere, typically 4% at the surface level. Liquid water is present on Earth, consists of 71% of the water bodies. It is found mostly in oceans and other large water bodies. Small amounts of water have been found in the inside of the volcanic pearls brought from Moon to Earth by Apollo 15 crew in 1971. NASA reported the detection of water molecules by NASA's Moon Mineralogy Mapper aboard the Indian Space Research Organization's Chandrayaan-1 spacecraft in September 2009. Water ice is present in the Earth mainly as ice sheets, glaciers, and polar ice caps holding 2.4% of the water. Below ground or in underground, the percentage of water that is found in aquifers is 1.6% and 0.001% in the air as vapor, clouds formed of solid and liquid water particles suspended in air, and precipitation. Oceans hold 97% of surface water, and other land surface water such as rivers, lakes, and ponds consists of 0.6%. A very small amount of the Earth's water is contained within biological bodies and manufactured products. let us discuss about the characteristics of water. Water has certain characteristics. These typical characteristics of water are grouped as under. First one, physical characteristics of water. Water is made available by the natural hydraulic cycle of the atmospheric, oceanic, terrestrial system. In most forms, water is a renewable resource since its continued flows are not affected by withdrawals or use. However, not all natural waters are renewable, and renewable waters can become non-renewable by human actions such as contamination, watershed modifications, or extraction in excess of inflow rate. Water is a vital resource for human and other animal and plant health. Water bodies provide habitats for aquatic life, provide moisture for vegetation and terrestrial biota, transporting nutrients between one ecosystem and another. As well, large water systems provide regional and climatic weather services. Large scale withdrawals or transfer of water can change ecological conditions. The economic characteristics of water. The international development community clearly expressed the need for applying economic tools and principles to water. The International Conference on Water and Environment held in Dublin, Ireland in January 1992 concluded, among other things, that water has an economic value in all its competing uses and should be recognized as an economic good. Water is used in economic activities and hence must be allocated among competing uses. The commercial needs for water resources complicate matters since water is difficult to measure and identify. As such, it is difficult to subject water to market forces in a market economy. Furthermore, water has a long-term value to the sustainability of life and economic activity over periods that dwarf those considered in conventional cost-benefit analysis. Now, social characteristics of water. It is commonly accepted that access to water is a basic human right. The Dublin Conference in 1992 asserted that it is vital to recognize first the basic right of all human beings to have access to clean water and sanitation at an affordable price. Moreover, it is argued that water is a social good in that the widespread availability of clean and affordable water improves both individual and social well-being. Clean water reduces the prevalence of water-related diseases, a social benefit shared by all users of the same water source. The public health impacts of inadequate water supply and sanitation has serious social and economic consequences for all. Now, political characteristics of water. In addition, water is not evenly distributed throughout the world and there are great variations in natural abundance. For example, mountain areas produce 80% of the global water resources, yet they have less than 10% of the global population. This uneven distribution entails the need for large-scale transfers and agreements. Previously, large-scale transfers of water occurred within national borders. Agreements were common among nations that shared a watershed such as US and Mexico. Recently, as domestic, industrial and agricultural demands for fresh water have grown, proposals for bulk water transfer are being made at the international level. Entrepreneurs have created a wide range of markets for water, leading to various forms of international water trading and exchanges. Thus, fresh water has become an issue in international trade, negotiations and disputes. The lack of legal precedents governing the trade of water has placed water at the forefront of international concern and tension. The above physical, economic, social and political characteristics of water make it a unique resource in which a degree of government involvement is inevitable. The discussion will now turn to the governance structures which have been implemented in order to manage and provide these complicated and vital resources. Distribution of water. Where is earth water located and in what forms does it exist? You can see how water is distributed by viewing these bar charts. The left side bar shows where the water on earth exists. About 97% of all water is in the oceans. The middle bar shows the distribution of that 3% of all earth's water, that is fresh water. The majority, about 69%, is locked up in glaciers and ice caps, mainly in Greenland and Antarctica. You might be surprised that of the remaining fresh water, almost all of it is below your feet as a groundwater. No matter where on earth you are standing, chances are that at some depth the ground below you is saturated with water. Of all the fresh water on earth, only about 0.3% is contained in rivers and lakes. Yet, rivers and lakes are not only the water we are most familiar with, it is also where most of the water we use in our everyday lives exist. For a detailed explanation of where Earth's water is, look at the data given in table 1. Notice how the world's total water supply of about 326 million cubic miles of water, over 96% is saline, and of the total fresh water, over 68% is locked up in ice and glaciers. Another 30% of fresh water is in the ground. Surface water sources such as rivers only constitute about 300 cubic miles, about 1000 part of 1% of total water. Table shows where the earth's water is. One estimate of global water distribution says that ocean, seas and bays contains 96.5% of the total water, whereas ice caps, glaciers and permanent snow consists of 1.74%. Groundwater estimates about 1.7%. Fresh and saline water is 0.76% and 0.94% respectively. Soil moisture water is 0.001%. Ground and permafrost is 0.022%. Lakes contains 0.013%. Atmosphere contains 0.001% of water. Swamp water contains 0.0008% of water. Rivers contains 0.0002% of water. And in the last, the biological water, the percentage of biological water is 0.0001%. So this is the actual distribution of Earth's water. Sources and supply of water. Surface water under river flow, desalination, groundwater and frozen water are the water suppliers. But the source of water to the earth is through water cycle, which is also called as hydrological cycle. Water cycle. The water cycle, known scientifically as the hydrological cycle, refers to the continuous exchange of water within the hydrosphere, between the atmosphere, soil, water, surface water, groundwater and plants. Water moves perpetually through each of these regions in the water cycle, consisting of following transfer process: evaporation from oceans and other water bodies into the air, and transpiration from land, plants and animals into air; precipitation from water vapor, condensing from the air and falling to earth or ocean; runoff from the land, usually reaching the sea. Most water vapor over the oceans return to the oceans, but winds carry water vapor over land at the same rate as runoff into the sea, about 36 trillion tons per year. Over land, evaporation and transpiration contribute another 71 trillion tons per year. Precipitation at the rate of 107 trillion tons per year over land has several forms, most commonly rain, snow and hail, with some contribution from fog and dew. Condensed water in the air may also refract sunlight to produce rainbows. Let us discuss about the utilization of water. Water resources are sources of water that are useful or potentially useful to humans. Uses of water include agricultural, industrial, household, recreation and environmental activities. Virtually all of these human uses require fresh water. 97% of the water on the earth is salt water, leaving only 3% as fresh water, of which slightly over 2/3 is frozen in glaciers and polar ice caps. The remaining unfrozen fresh water is mainly found as groundwater, with only a small fraction present above ground or in the air. Fresh water is a renewable resource, yet the world's supply of clean fresh water is steadily decreasing. Water demand already exceeds supply in many parts of the world, and as the world population continues to rise, so too does the water demand. Awareness of the global importance of preserving water for ecosystem services has only recently emerged, as during the 20th century, more than half the world's wetlands have been lost, along with their valuable environmental services. Biodiversity rich freshwater ecosystems are currently declining faster than the marine or land ecosystems. The framework for allocating water resources to water users, where such a framework exists, is known as water rights. Uses of fresh water can be categorized as consumptive and non-consumptive, sometimes called renewable. A use of water is consumptive if that water is not immediately available for another use. Losses to subsurface seepage and evaporation are considered consumptive, as is water incorporated into a product such as farm produce. Water that can be treated and returned as surface water such as sewage is generally considered non-consumptive if that water can be put to additional use. Water resources are used in various ways, including direct consumption, agricultural irrigation, fisheries, hydropower, industrial production, recreation, navigation, environmental protection, the disposal and treatment of sewage and industrial effluents. Water has sources and supplies, economic, social and political characteristics which make it a unique and challenging natural resource to manage. The uses of water. Agricultural use. It is estimated that 69% of worldwide water use is for irrigation, with 15 to 35% of irrigation withdrawals being unsustainable. In some areas of the world, irrigation is necessary to grow any crop at all. In other areas, it permits more profitable crops to be grown or enhance crop yield. Various irrigation methods involve different trade-offs between crop yield, water consumption and capital cost of equipment and structures. Irrigation methods such as furrow and overhead sprinkler irrigation are usually less expensive but are also typically less efficient because much of the water evaporates, runoff or drains below the root zone. Other irrigation methods considered to be more efficient include drip or trickle irrigation, surge irrigation and some types of sprinkler systems where the sprinklers are operated near ground level. These types of systems, while more expensive, usually offer greater potential to minimize runoff, drainage and evaporation. Apiculture is a small but growing agricultural use of water. Freshwater commercial fisheries may also be considered as agricultural use of water, but have generally been assigned a lower priority than irrigation. As global population grow and as demand for food increases in a world with a fixed water supply, there are efforts underway to learn how to produce more food with less water through improvements in irrigation methods and technologies. Agricultural water management, crop types and water monitoring is essential to save and conserve water. Now, industrial use of water. It is estimated that 22% of worldwide water use is industrial. Major industrial users include power plants which use water for cooling or as a power sources, that is hydroelectric plants, ore and oil refineries which use water in chemical process, and manufacturing plants which use water as a solvent. The portion of industrial water usage that is consumptive varies widely, but as a whole is lower than agricultural use. Water is used in power generation. Hydroelectricity is an electricity obtained from hydropower. Hydroelectric power comes from water driving a water turbine connected to a generator. Hydroelectricity is a low-cost, non-polluting renewable energy source. Water is also used in many industrial processes and machines such as steam turbine and heat exchanger, in addition to its use as a chemical solvent. Industry requires pure water for many applications and utilizes a variety of purification techniques both in water supply and discharge. In household, drinking water is used. It is estimated that 8% of worldwide water is used for household purpose. These include drinking water, bathing, cooking, sanitation and gardening. Because household water requirements have been estimated by Peter Gallick at around 50 liters per person per day, excluding water for gardens. Drinking water is water that is of sufficiently high quality so that it can be consumed or used without risk of immediate or long-term harm. Such water is commonly called potable water. In most developed countries, the water supplied to household, commerce and industry is all of drinking water standard, even though only a very small portion is actually consumed or used in food preparation. Food processing requires water. Water plays many critical roles within the field of food science. It is important for a food scientist to understand the roles that water plays within food processing to ensure the success of their products. Recreation. Recreational water use is usually a very small but growing percentage of total water use. Recreational water use is mostly tied to reservoirs. If a reservoir is kept fuller than it would be otherwise be for recreation, then the water retained could be categorized as recreational usage. Release of water from a few reservoirs is also timed to enhance whitewater boating, which also could be considered a recreational use. Other examples are water skiers, nature enthusiasts and swimmers. Recreational usage is usually non-consumptive. Golf courses are often targeted as using excessive amounts of water, especially in drier regions. Aquatic life forms. Earth's water are filled with life. The earliest life forms appeared in water. Nearly all fish live exclusively in water, and there are many types of marine mammals such as dolphins and whales that also live in water. Some kinds of animals such as amphibians spend portion of their lives in water and portion on land. Plants such as algae grow in the water and are the basis for some underwater ecosystem. Aquatic animals must obtain oxygen to survive, and they do so in various ways. Chemical uses. Water is widely used in chemical reactions as a solvent or reactant and less commonly as a solute or catalyst. As a heat transfer fluid, water and steam are used as heat transfer fluids in diverse heat exchange system. Due to its availability and high heat capacity, both as a coolant and for heating. Condensing steam is a particularly efficient heating fluid because of the large heat of vaporization. A disadvantage is that water and steam somewhat corrosive. In almost all electric power stations, water is the coolant which vaporizes and drives steam to turbines to drive generators. In the nuclear industry, water can also be used as a neutron moderator. The entire episode highlights the importance of water, which is essential to entire biosphere. Water use has grown rapidly in modern times. The first 80 years of the 20th century saw a 200% increase in the world's average per capita water use, which accounted for a remarkable 566% increase in withdrawal from the world's freshwater resources. In addition, a significant portion of water resources have become unusable due to industrial and agricultural pollution. Water resources refer to the supply of groundwater and surface water in a given area. Water resources may also reference the current or potential value of the resources to the community and the environment. The maximum rate that water is potentially available for human use and management is often considered the best measure of the total water resources of a given region.